Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
This problem needs to be solved using conservation of energy. The conservation of energy principle tells us that the total initial energy equals the total final energy. We're given some things in the problem that are important to know. The angular frequency of the spring is 7 radians per second. We're told that the block is sliding along a floor that is frictionless, so there is no heat loss due to friction. We're told that the block has no thickness. The thickness of it does not matter. So we're going to assume that the center of that block is at its initial position 0.050 meters, which we're told in the problem, away from its rest position. X rest is 0 meters. And we're told that there's a bottle placed 0.080 meters away from that same rest position. The problem also states that we want the block to slide, and we want to know what velocity it needs to be pushed with initial velocity v0, such that any velocity higher than that, it will strike the bottle. So we're going to solve for what v0 will be if it just stops when it gets to the edge of that bottle, and then that will tell us the values greater than that we'll need in order for it to strike the bottle. In terms of energy, we know that there is some initial spring potential energy. The equation for that is 1/2 k, in this case x0 squared. There's also going to be some initial kinetic energy. The equation for that is 1/2 mv initial squared. And when it gets right next to the bottle, it stops. So kinetic energy will be 0, but there will be spring potential energy, and that's the final spring potential energy, 1/2 k x squared. So I'm going to plug those equations into my conservation of energy equation. And so we're going to say the initial kinetic energy plus the initial spring potential energy is going to equal the final spring potential energy. I plug in my equations for each of those forms of energy. 1/2 m v0 squared plus 1/2 k x0 squared equals 1/2 k x squared. Now you'll notice in this equation there's several things we don't know. We don't know k, we don't know m, we don't know v0. We do know the x values, but that's not enough to solve the problem. So how do I figure out other things in this problem? Well, given that we know the angular frequency of the spring, we do know the equation for spring angular frequency is the square root of k over m. And if I substitute in my value given in the problem for omega, 7 radians per second equals the square root of k over m, I can actually solve that for k. The way I would do that is square both sides of the equation. You get 49 equals k over m. And if I solve that for k, you get 49m equals k. All I did was multiply both sides by m here, and the m's cancel, and you're left with 49m. So this is the value I can use for k in my equation, and that will be very helpful in getting the solution. So let's go ahead and substitute in now what we know. So I have 1/2 m v0 squared plus 1/2, now for k, we're going to substitute in 49m, and x0 is 0.050 squared, and that equals 1/2 k, 49m, times x final squared, 0.080 squared. Notice several things can be canceled now. 1/2 is distributed everywhere in the equation, so that goes away. I don't need to worry about that in my solution. And mass is distributed everywhere, so that also can be canceled from the problem. And now we're just left with v0 as my only variable. So now I solve this. v0 squared plus 49 times 0.05 squared, so that's going to be 49 times 0.0025 equals 49 times 0.080 squared is 0.0064. I'll continue my solution here. v0 squared plus 49 times 0.0025 is 0.1225, but I need to leave two significant digits. So we're going to write it as 0.12 equals 49 times 0.0064 is 0.3136, but with significant digits, I have to round it to 0.31. Now I subtract 0.12 from both sides, and you get V0 squared equals 0.19. To finish, I take a square root of both sides, and you get V0 equals, and technically it's plus or minus because it's a square root, and the answer would be 0.44, I guess I should say 0.44 meters per second. My answer has two significant digits. One thing that's significant about the plus or minus is you could push a block either to the right or to the left, and you get the same result. If you pushed it to the right at 0.44 meters per second, it would still stop right at the edge of the bottle. And so you can push it either right or left, and anything greater than 0.44 would strike the bottle.